Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about coordinate geometry of the circle. Now the question I've chosen to go through is 2019 paper 2 question 4. In this question we're given a square which is PQ or S, and inside it is the circle C. But for the first part of this question we're not concerned with the circle. We've been given the coordinates of OR, the coordinates of S and the coordinates of P. We've been asked to find the coordinates of Q. What you need to realize in this question is that the distance and direction from S to P is the same as the distance and direction from OR to Q. Which means this is a translation. It's very similar to the last part of question 2 in this paper. I need to figure out what happens to the X value and the Y value in order to go from S to P. And I need to do the same thing to go from OR to Q. So S is -4, 11 and P is 2, 3. In order to move from S to P, I would have had to add 6 to the X value, because -4 plus 6 gives you +2. And I would have had to subtract 8 from the Y value, because +11 minus 8 gives you +3. So that's what happens in order to go the distance and direction from S to P. I want to go the same distance and direction from OR to this unknown. In other words, I want to add 6 to the X value of OR and subtract 8 from the Y value of OR. So 4 plus 6 gives me 10 and 17 minus 8 gives me 9, which means that the coordinates of Q are 10, 9. Okay, now for part B, I've made a very feeble attempt at drawing the circle, but it doesn't matter for the moment. We're asked to find the center of the circle C, somewhere in the middle here. You need to realize that this is a perfectly symmetrical diagram. The center of the circle will be the midpoint of the line that joins S to Q. It's the midpoint of the line SQ will tell me the center of the circle. So that's the way I'm going to do it. All we need to do is get the midpoint of this point and this point. What you also could do there is get the midpoint of ORP, because obviously this is a diagonal as well. If we were dealing with that, another way of finding the center of the circle is just the midpoint of ORP. But in this case, I'm going to take the line SQ and I'm going to find its midpoint, and I know the midpoint of that line is the center of the circle. So once you've identified the center of the circle is just the midpoint of SQ, it's a relatively straightforward question. You should go to your maths tables on page 18, where you find the formula for the midpoint of a line. It's x1 plus x2 over 2, y1 plus y2 over 2. I already know S is -4, 11, so that's my x1 and my y1. Q is 10, 9, that's my x2 and my y2. Remember, those are actually interchangeable. I could have called this x2, y2 and this one x1, y1. You end up with the same answer either way, so it doesn't really matter. Here all I did was plug them all in, and I end up with 6 over 2, which is 3, and 20 over 2, which is 10. So the midpoint of SQ is 310, or in other words, the center of the circle C is 310. Okay, in part C, we're asked to find the length of the radius of the circle. Now what you need to realize here is that the radius, let's first think about the diameter. The diameter is the distance from, say, here through the center to here. What I want you to recognize is that the diameter of the circle is the same as the distance from P to Q or the distance from S to OR. Now if you can find the diameter, to find the radius you just divide it by 2. So all I need to do here is find the distance from P to Q. Let's say that the distance works out as 10. When I use my distance formula, let's say it works out as 10. If I just divide that by 2, I could say that the radius would be 5. So all we need to do in this question is find the distance from P to Q, or the distance from S to OR. You could find any of them, to be honest. You could find ORQ or SP. In this case, I'm going to use the distance formula to figure out the distance from P to Q. That's the diameter of the circle. Just divide it by 2, and that tells me the radius of the circle. So in order to get the distance from P to Q, I just need to use my distance formula. If you go to page 18 in your maths tables, the distance formula for the distance from the point P to the point Q is the square root of x2 minus x1 squared plus y2 minus y1 squared, where I label this as x1, y1 and x2, y2. So all I did on the next line was sub everything in, and I end up with the distance PQ is the square root of 100. The square root of 100 is just 10. Now look back at your diagram. Remember that the distance from P to Q is also the diameter of the circle C. If you know the diameter, in order to find the radius, you just divide it by 2. 10 divided by 2 gives me 5. So I could say that the radius of the circle is just 5 units. In the final part of this question, we're asked to find the equation of the circle C. You should realise that the formula for the equation of a circle is on page 19 in your maths tables. And it's given as x minus h to be squared plus y minus k to be squared is equal to r squared. You need 2 pieces of information in order to get the equation of a circle. You need to know the centre of the circle and you need to know the radius. We've already worked both of these out. The centre of the circle, if you're using this formula, is the x value is your h, the y value is your k. And clearly r is just going to represent our radius. So all I did here was I subbed in. Instead of h I subbed in the 3, instead of k I subbed in the 10, and instead of r squared it's 5 squared. Now you're not expected to multiply out the left hand side, you can just leave it as it is. But you do have to square the right and say that 5 squared is equal to 25. So this is your final answer for part D. Now I hope all of this video makes sense. If there's anything you're struggling with there or you'd like me to clarify something, let me know in class or send me an email and I'll explain it differently.